Hello, MUS 1002 students. In this, our final chapter, we are going to take a brief look at sound and music in films and video games. Let's begin with film. So, in the beginning, there was black and white film, and it was silent. Dialogue was shown as title cards that were projected after the actors had acted and performed their lines. It wasn't very sonic or impactful. You would watch the actors act, you would see them emote, and then you would see a single line of text on a card, maybe more. If there were soundtracks, and there were, they were performed live by professional musicians. For large premieres, studios would actually go out and hire an entire orchestra with a conductor. Large theaters would frequently have a theater organ, which was an organ built to emulate many of the sounds of an orchestra. So you'd have trumpet sounds, flute sounds, a bassoon, somewhat string-type sounds, and a variety of percussion instruments built into the organ console. In smaller venues, you would have a single person playing a piano, or you would just have pre-recorded music played on a record that they hoped would sync up with the action on screen. Sound on film technology was first developed in 1923, and by the early 30s became the standard for films. This leads us to the talkie era. The first major talking film was by Warner Brothers in 1927, The Jazz Singer, starring Al Jolson. It was actually mostly silent, but it did have a couple of scenes of Jolson singing. It was an incredible hit. The plot's okay, but mostly it was the novelty of, hey, there's sound with a film that's on the film. Go check it out. Kind of like 3D or IMAX or stuff like that. But to compete with that, Universal Pictures decided to up the ante and create an entire musical production in 1929 for Showboat. Note that this is not the Broadway musical Showboat, but they are both inspired by the same book. There was a problem, though. Early mics could only handle the dialogue with other sounds that were important to the on-screen action, either being too quiet to record or so loud that they would distort the mics. So, the solution was to hire Jack Foley, an actor in local theater, a set builder, a stuntman, and an assistant director, to come and assemble a team and perform sound effects in post-production after they had finished shooting the film. So Foley assembled a group of his friends, a bunch of props, a couple of mics, and they went into a soundstage. And at that point, they projected the film, turned on the mics, and started recording as Foley and his friends performed the all-important sound effects that were needed for the film. Things like footsteps, crowd murmurs, hand clapping, and just everything else that went into there. Creaking doors, creaking planks, any type of impact sounds. All of that was recorded in sync with the film. This is the first instance of what became known as Foley art, with Foley frequently being hired by studios to perform sound effects in post-production to enhance the illusion of reality of the films. And that's all that Foley art is. It's performing sound effects in sync to a film to heighten that illusion of realism for the viewers. Nowadays, it is a standard part of the filmmaking process. Now, there's some interesting stuff with this. Foley kept working up through the 60s, and especially during the golden age of Hollywood, a lot of the work that he was involved in and that other sound effects producers were involved in involved foot syncing, effectively the dance cues for the popular musicals of the day. And in fact, some of the actual stars, like Gene Kelly, would dance their own parts In his case, mostly because they were simply too hard for others to try and recreate. Fred Astaire is noted to have done a couple, as is Ginger Rogers. But for almost all of the other dance cues, it was necessary to hire trained dancers who would learn all of the choreography and dance it in sync with the actual film. The result was that many, many women were hired to do the dance cues and then just kind of fell into becoming Foley artists in their own right. They would start off doing the dance cues. Then they would do a couple other sound effects as needed, maybe some hand claps or some crowd murmurs. Then they would be pulling light switches, and pretty soon they were breaking vegetables to create bone breaking in early 1950s sci-fi and horror films. In fact, Foley has a history of being the one area of sound and music technology that has the greatest number of women working in it, up until the present day. But beyond the sound effects, the most important part of the film is the dialogue, at least from a sonic perspective. The visuals are important too. More than any other part of the sound, the dialogue advances the story and has to be the most prominent auditory feature. But there's a problem. Sometimes it's just not possible to get the dialogue right on the set. You might be filming outdoors on a windy day, and you're just going to get nothing but turbulence. You're just going to hear whoosh type noises from the wind in the microphone, and it's a pain. So we have automated dialogue replacement, or ADR, sessions to overdub and replace lines in post-production. In addition to working out the dialogue for problematic shoots, it's also used for all animated films, foreign language dubs, and to create censored versions of films and other media for airline and TV distribution. But as important as dialogue is, it doesn't really fill in everything. How do you add emotion, nuance, locational cues, or character themes? To do that, you need the film score, the music that is used to enhance the visuals beyond sound and dialogue. So creating a score is a process. Before any music is written, before the composer sits down at the piano, they spot the film, where the composer, the director, a bunch of assistants all sit together with a cue sheet, and they make notes where every musical cue will start and end using time codes that are projected with the film. Spotting is also used when you need to sync particular sounds in a score to the action on a film, which is extremely common in a cartoon. When you have slide whistles where someone is falling, or when you have the skeletons dancing and one of them is playing the ribs of another like a xylophone, and you need to have those hits sync up. Once this film is spotted, the cues are given to the composer, who imports the film into a DAW, has a video window open, big time clock, and creates a template of all of the instruments to be used in the score. Then, in the DAW, they will use that large time clock to go to specific times that were defined on the cue sheet and insert markers that define the important parts in the score and use them to create regions of empty space on a MIDI track that's as long as the cue. That blank track is then used to translate time codes, which are hours, minutes, seconds, to bars and beats and tempo information. This is a bit of a simplification, but it's enough for this class. If you really want to get into this, come to office hours and I will show you part of the process. With that prep work done, the composer is scoring the cue by entering in MIDI information, usually on a keyboard, to create a mock-up of the score using sample instruments. That way they can take it back to the director and the producer and have a listening session and say, okay, this is good. Or we need to change this, or we need to make this a little tighter. Maybe can we add a couple of different drums here, Like, I like what you're doing with the snare, but we need something a little bit more impactful. Let's go with maybe a taiko drum. When working in film or on a small budget TV show or similar, that mock-up will be very similar to the final version. In fact, it's usually going to be the final version. They just run it through a really good sample library like East West or Vienna Symphonic Library. But for large budget pictures, the MIDI data for each cue is going to be exported and converted in a score editor to music notation and given to the musicians and a conductor to record. In this case, the conductor will be monitoring the film on video and listening to a click track that syncs up to the metronome for all of the cue in headphones. He'll be conducting everything while listening to that click track, and the musicians will be playing in sync, and all of that will get recorded and printed into the final film. When mixing all of the cues, it's really common to put them into sub-mixes. This is a standard technique that just makes life really, really easy. That way you have one channel control for all of the Foley cues globally, one channel of control for all of the dialogue cues globally, and one for all of the musical cues. That way you're only moving 3 different faders or panning knobs at any given time. You can still go into the full mix and edit individual cues, but you have the ability to bring up all of the music cues or bring down all of the Foley cues much, much easier than trying to do that when, you know, you can end up with 200 plus different channels of audio. But once it's mixed, the final audio is added to the film render and it is ready to watch and make sure that everything is perfectly in sync. And then it's on to distribution to theaters, TV, Netflix, wherever. And here is a picture of a film scoring example that I used in one of my advanced music tech classes. In this case, you can see I have a video window with a film in there. It is a very, very insane documentary I found online called How to Cook Frozen Meat. Thank you, government films, for not being copyrighted. I have a giant clock here that is showing exactly where things are. The format is hours, minutes, seconds, and frames. So here we're at 5 seconds and 22 frames. There are 24 frames per second, so this is just before the start of 6 seconds. In the actual editor, which I'm using Reaper for this, you can see up at the top I have a lot of numbered markers for various dialogue lines and Foley cues. Because this is only a very, very short, about 4.5 minutes long, I only have one musical cue, so I just needed to indicate where that musical cue starts. I didn't need anything else, really. But for longer films, it would be considerably larger, and I would actually be using what are called sub-projects, where instead of having a track for the dialogue subgroup, I would have a track that would be the Q1 project, the Q2 project, and it would have all of the dialogue for the cue. It would have all of the musical information for that cue in there in that project. But very cool, very fun thing to work on. And that leads us to video games. Video games, the process for creating sound effects and music is very similar to films, except you don't have to do anything in sync because everything is going to be synchronized with code. Every sound effect in a game is recorded in isolation, but when you play the game, it's triggered by an action. For example, pressing a button to fire a gun, or pressing a button to jump, or if an enemy sees the player character, the AI will trigger it to shoot at the player. You have footsteps when moving the analog stick, stuff like that. Music in games needs to be loops that seamlessly and transition smoothly when any changes happen. So to make this work, You have game engines like Unity 3D and Unreal that let the sound designer attach sounds to game objects and then control them with scripts. And a script is simply a small segment of code that tells objects how to interact with other objects or what to do once a condition is met. So if I insert a script on the player character, I can say, okay, whenever you press the jump button, play this sound. Pretty easy. And here is a quick view of the Unity editor showing just a bunch of scripts. Those are the files with the pound sign or the hashtag or the sharp sign, depending on your background on them. That is appropriate because the language that is used for scripting is C#. But scripting every single audio effect and musical cue would be a huge problem in terms of time. So most games use what's called middleware. Middleware is software that provides an extension of services to a program, making it easier to manage and control sounds in relation to the game engine. For games, the most popular audio middleware engines are FMod Studio and Wise. This allows the sound designer and composer to create events that randomize selections of related sound effects. So for example, if I'm scoring a hack and slash sword and sorcery type game, I might have 30 different examples of two swords clanging together. And I might have that all in one cue in FMod. And every time that cue is triggered, it will randomly select one of those 30 sword impact sounds. I can have the middleware respond to scripting from the game engine to control effects and physics of the sound. So that if, for example, I have a character that is over on the extreme right side of the screen and an enemy on the left, the enemy fires a laser, the laser will go towards the character. As it's getting closer to the character, I'll hear it increase in volume and I'll have a little bit of a pitch shift for the Doppler effect. And I can do that in 2D or in 3D. And on top of that, I can also mix the audio and the loops for the audio in the middleware and then put them into the game world itself. And this is really easy to do. I add what's called an audio emitter object to objects or prefabs of objects in the game. So every enemy will have the same set of audio files that it will choose to emit from. Then I have an audio listener object attached to the player or to the camera if we're doing a first-person perspective. Then audio is generated from the emitter, and the middleware calculates the distance between the emitter and the listener. And it will increase volume, it will increase pitch, it will add reverb if necessary. All of that is handled by the middleware, so I don't have to do 5,000 different cues from different distance perspectives. So this is incredibly, incredibly useful. It simplifies so much of the work of the sound designer. And I can test all of this inside the middleware. I can test it by combining the middleware with the game engine as the game is being developed and hear how my cues are working just by trying a quick level of any scene in the game. In the case of music, the cues can be created using different looping regions that are randomized. So this creates a musical score that changes and evolves over time. So you're not just hearing the same 10-second loop over and over, but that instead it's got related parts that it will choose from. So I might have loop 1, then it goes to part 5, loops again, go to part 6, loops again, goes back to part 1, loops a third time, fourth time, whatever time, goes to number 10, and all of this will change and create subtle variations. It can also be set to use trigger parameters. So for example, if I have a character that's walking outside under the sun and then goes into a cave, that all of a sudden the middleware will apply an appropriate amount of cave reverb. Or things that will change based on the condition of the game world. That if the game world is in daylight, I will hear birds chirping and little squirrels running around. But if the game goes to a nighttime type scene, then instead of hearing birds chirping, that will fade out. I might hear the occasional owl hooting or a wolf in the background. Here is a little picture of a Fmod Studio object. This is a single event that is taking 23 different sound effects to create the effect of what I called an ancient alien. And every time that character is triggered in the game to make a sound, it will select one of these at random and play it. Then here is an example of a game I scored where I have different loops set up so that for the game over music, it will choose a drum loop, a bass loop at random, and then it will transition into the game over version of that. And then it will also add the game over flourish on top of the previous drum loop and bass loop so that it will have a roughly seamless transition from the scene of playing the game to the scene of game over. So it takes a bit of time to get used to working in a game engine and in middleware. But in addition to working with that to create video games, it's also becoming a very popular option for composers. Game engines can be used to create interactive visual programming for performances. They can be integrated with open sound control protocols to control instruments, and they can create really interesting VR installation works. I know there's a couple of very, very cool works out there. You should check out Nick Wang, who teaches at University of Wisconsin currently, and Mike McFerrin, who teaches at Lewis University in Chicago. Both have done very, very interesting things with game engines. Also, Teenage Engineering's OPZ synthesizer uses Unity scenes natively to create interactive visuals based on what you're doing on the synth itself or what you're sequencing on it. It's very cool. It just has an HDMI port for output, and it sends that out to a projector that will react in real time to whatever sound you're creating. But I will leave you as a final slide with an example of another approach to creating sound with a game engine. This is a screenshot from the beginning of a piece I did called Fever Swamp for clarinet and video game engine. And there are a bunch of cues in it. There's about 50 of them. But for every cue, it's created by the position of the player in the world. And it will glitch out the visuals. It will change the audio that you hear based on the listener that's attached to the camera and what it hears from the emitter objects. But based on what cue number you're on, it will also change the score that's displayed for the live clarinetist to play. So just another way that composers are playing around with game engines and experimenting and using them to create new music.